So first of all, a little review of reciprocals from yesterday. So whenever you have a 1 over graph, all you're changing is the y values from the graph on the bottom to 1 over y. That's the simple part. What happens with the graph? Well, there are some interesting situations like x-intercepts. So on my sine graph, I have a bunch of x-intercepts. And if the y value is 0, you would get 1 over 0, you get a non-permissible value. And just like in our rational functions unit, whenever you have a non-permissible value, you either have a whole or a vertical asymptote. Obviously, there's going to be nothing that cancels out with the top because the top is 1. So all of these x-intercepts on the reciprocal graph will become vertical asymptotes. So we have a lot of them, and then we continue on forever. I'll just label 1, right? Remember, you always label vertical asymptotes x equals, so that one would be at x equals pi. Next, on reciprocal graphs, you look, does the original graph go either up forever or down forever? And a lot of the graphs that we did yesterday had that happen. Notice with the sine graph, it stops at 1 as the highest point, and its smallest point is -1. So there's going to be no horizontal asymptote at y equals 0. We have that horizontal asymptote on a reciprocal graph when your graph has y values that get very, very big. And then the last thing you do is just find some nice points. Well, like this is a really nice point. Pi over 2 comma 1. And if you switched pi over 2 comma 1, you would get 1 over 1, which stays the same. In fact, all of these points that have a maximum of 1 are going to stay the same. And all of the points with a minimum value of -1, because if you took a y value of -1 and did 1 over -1, it would stay the same. Now, on my original graph, I could have a point like here. You know from your pi plate, which, again, you need to have that memorized for your provincial final in a week. They will give you an empty circle at the beginning of the test that you can rip out, and maybe you fill in quadrant 1. But you have to have that re-memorized again for the exam. So I know that sine of pi over 6 is 1/2. If I do the reciprocal of 1/2, that just flips that fraction. I'm going to get pi over 6, comma 2 over 1, which is just pi over 6, comma 2. And in fact, each of these parts is going to go towards the asymptote. And this is the graph of cosecant. So if we know the ideas of graphing reciprocals, how to work with the asymptotes, how to take points and change the y value to 1 over y, you're going to be able to graph the reciprocal of anything. So here's a cosecant graph. It sometimes shows up on the provincial exam. Some of you noticed some of these in the reviews already. Next, we could do the graph of secant. So what would we do? We would start by drawing the graph of cosine. Remember, cosine starts at a maximum, period of 2 pi. So everywhere where cosine has an x-intercept, those will become non-permissible values. And in the graph, those non-permissible values will become vertical asymptotes. And again, I have a lot of them on this graph. I'm just going to label one of them. One of them would be at x equals pi over 2. Just like sine, the graph of cosine does not go up to infinity or off to negative infinity. So we don't have an asymptote at y equals 0. And nice points. Again, wherever things are 1, 1 over 1 would be the same. So all of these would stay the same. And same thing with minus 1. All of these points would stay the same. And the graph of secant looks very similar to the graph of cosecant. And finally, we get to the graph of cotangent. And cotangent is the one reciprocal graph that has some exceptions. And it has some exceptions because you have two identities for cotangent. You know that cotangent is 1 over tangent. You also know that cotangent is what over what?
Cos theta over sin theta.
Cos theta over sin theta. And you use both of those when you're proving identities. The graph of 1 over tangent is slightly different than the graph of cos theta over sin theta. Slight. And we're going to find out what do mathematicians decide to do with the graph of cotangent. So on the graph here, I have the graph of tangent. The graph of tangent has asymptotes at pi over 2, negative pi over 2, 3 pi over 2, and so on. That's all the places on your unit circle where it was not possible, at the top and at the bottom. And it has asymptotes, it has x-intercepts at 0, pi, 2 pi, 3 pi, 4 pi. So at those values, where tan is equal to 0, you would notice that those are the same values where sine is equal to 0. So whether we graph cotangent as 1 over tangent or as cos theta over sine theta, we would have all of those as non-permissible values. So we're going to have on our cotangent graph a lot of asymptotes. And I'll label one of them at x equals pi. Now at pi over 4, tangent of pi over 4 is 1. Cos of pi over 4 divided by sine of pi over 4 is also equal to 1. And so, every point where the y value is 1, That's going to be an invariant point. And every point where the y value is minus 1 is also going to be an invariant point. And this is where the cotangent graph is unique. So normally, my tangent graph goes off to infinity. Normally, on a reciprocal graph, that would cause you to draw an asymptote at y equals 0. But in the case of cotangent, they've decided to graph cotangent as cos over sine more than as 1 over tangent. And the way that you can see this is if we take a value like pi over 2. Tangent of pi over 2 is undefined. But cos of pi over 2 is 0. And if I plugged in plug in this one in here, it's not possible because you're not allowed to take tangent of pi over 2. But if I plug in pi over 2 into this one, cos of pi over 2 is 0, sine of pi over 2 is 1, 0 divided by 1 is 0. And if you think at the top, right, when we did our unit circle, at the top, at tangent of pi over 2, we wrote 1 over 0 and said that's why it's not possible. But if you do the flip of that fraction, now you get 0 over 1, and it is possible. So for cotangent, all the places where tangent is undefined, it's actually equal to 0. And the graph of cotangent is similar to the graph of tangent, just sort of in the opposite direction. So the cotangent graph is probably, of all the trig graphs, that's the hardest one. Because it follows most of the reciprocal rules, but not completely.